Where is everybody? If there are dozens of advanced alien civilizations in the Milky Way galaxy alone, why haven't we found them? Are we truly alone in the cosmic vastness? Well, we might not even be part of the universe at all. But if we are, we better stop the search for alien civilizations for our own sake. Back in the mid-20th century, the conversations around aliens and the possible existence of other civilizations within the galaxy were gaining traction. Such was the case on a summer day in 1950 when Italian-American physicist Enrico Fermi went out for a lunch with 4 other physicists at the dining room of the Los Alamos National Laboratory. Drifting across different topics within the science sphere, they eventually found their way talking about alien civilizations. They agreed that based on logic, there should be other civilizations in the universe. It was during this discussion that Enrico Fermi felt the need to ask the iconic question, where is everybody? This single question became the foundation of the disparity between the possible existence of extraterrestrial intelligence and the obvious lack of evidence. Trying to understand the problem in depth, Dr. Frank Drake worked out his famous mathematical model. The Drake equation offers us a probabilistic idea of how many extraterrestrial civilizations exist in the Milky Way galaxy, using details like the mean rate of star formation and the fraction of stars that have planets, among other factors. Since then, scientists have continued to scout and search the far corners of our galaxy, but to date, no sign of alien life has been found. And here's why. In the 90s, Robin Hanson proposed a solution to the Fermi Paradox called the Great Filter. This solution suggests that intelligent interstellar life forms must cross several hurdles, one of which must be highly improbable. But what exactly are these hurdles that must be surmounted for a civilization to become truly advanced? The very first criterion for a planet to harbor life is that it must be within the Goldilocks or habitable zone of its star. This would facilitate the existence of life on the planet. But more importantly, the life form must be able to multiply using molecules like DNA and RNA. Another significant obstacle that must be navigated is that simple cells like prokaryotes must evolve into complex cells called eukaryotes, and multicellular organisms must develop as well. Critically, sexual reproduction, which is key for genetic diversity, must also happen. Moving on, complex organisms capable of using tools must develop while creating many advanced technologies needed for space colonization. Scientists believe this is the point where human civilization is today. The next stage would be to colonize other worlds and star systems without destroying our civilization. Currently, it seems we're still a long way off this milestone, and perhaps it might be the hurdle that we're supposed to be unable to cross. But on the other hand, we currently have a few spacecraft in the interstellar world, so maybe we're on our way to discovering and possibly colonizing another civilization without destroying our own. Despite the optimism among scientists, the rare Earth idea reckons that we might never find another civilization. This hypothesis, brought forward by Peter Ward and Donald Brownlee in 2000, suggesting that the conditions that support life here on Earth are so complex and exceptionally uncommon that it will be very difficult to find them anywhere else in our universe. Ward and Brownlee went further to list the numerous characteristics that facilitate the development of complex life on Earth. They include the planet's location, orbit, and tilt, among other things. In theory, for life to exist on a planet, it must be located in a favorable section of the right kind of galaxy and within the right range of heavy elements, and far enough away from high radiation sources. Also, the planet must orbit its star in a habitable zone. This means it must be located at a perfect distance from the star, where water can exist on the planet as a liquid. Additionally, the planet's tilt must allow seasonal atmospheric changes to provide a more or less clement climate. But that's not even enough, as a big protective planet is also needed. One that can shield it from colliding with asteroids and other celestial elements. In Earth's case, Jupiter is the one that shields us from this danger, with its enormous gravitational pull. Other factors or features include the size of the planet as well as that of its moon. Not only must the planet be large enough to support an atmosphere and liquid oceans, but the moon or moons must also be substantially large to help stabilize the tilt of the planet's axis. And lastly, the planetary core must be able to produce a magnetic field that would protect the surface from solar radiation. But the list goes on, and a few other things must also be available, like the presence of oxygen and plate tectonics. However, we must emphasize that the rare Earth hypothesis only applies to the existence of complex life, mainly because bacteria and other microorganisms that can represent simple life are believed to exist all across the universe. Interestingly enough, Russian-Soviet engineer Constantine Sulkowski got involved in the whole Fermi's paradox controversy before Enrico Fermi even asked his famous question. In 1933, Constantine had his say about the possible existence of aliens in our galaxy, and unlike the Great Filter and the rare Earth theories, his submission was much more precise and scary. The aerospace engineer believed that aliens not only existed, but they're a far more advanced civilization than humans. According to Constantine, these other civilizations know they're superior to us. They see us in the same way we see bacteria and observe us in secret without revealing their presence. Since they're more intelligent and advanced than us, the upcoming Moon and Mars missions will probably be routine to them. But they'll most likely be watching us all through the way as we attempt to achieve them. About 4 decades later, radio astronomer John Ball made a shocking revelation along these lines when he claimed that aliens have set us aside as part of a wilderness area or zoo. Thomas Kuiper and Mark Morris took it one step further in 1977 when they opined that aliens had kept us in some sort of quarantine bubble pending until we could offer something valuable. While the Drake theory equation seeks to calculate the number of intelligent life that may exist in our universe, it doesn't really factor into consideration that civilization is born and at the same time can also die. With that said, in 2015, 2 astronomers from the Space Telescope Science Institute estimated that the probability of other civilizations existing is around 92%. But unfortunately, 92% of Earth-like planets are yet to be found. In fact, the study shows that they are yet to be formed. In that sense, it is believed that humans are the firstborn of the universe, because we're the first ever civilization to exist. While this may sound like a good achievement, it had some bad implications to it. For instance, it is believed that our existence could have hindered the existence of other civilizations. And since we're the earliest to arrive in the universe, we will most likely be the first civilization to go extinct. Like the zoo hypothesis, the dark forest theory agrees that other life forms exist within the Milky Way. But we're better off not meeting them. Pioneered by Liu Cixin in his fiction novel The Dark Forest, this hypothesis is used to ascertain what other civilizations will do to us. We don't know if they'll be accommodating or hostile. With this in mind, Liu speculated that the natural instinct among the different civilizations would be to destroy other life forms before they get a chance to do the same to them. So basically, this means that humans have to become some sort of alien hunters and try to wipe out aliens and any other civilization that exists. In the same way, aliens and other life forms will be looking to annihilate us before we even get a chance to destroy them. If this were to happen, it would lead to chaotic scenes across the universe. But thankfully, humans have decided not to adopt the dark forest theory. In fact, on both Voyager spacecraft that are currently sailing through the vastness of the interstellar world, scientists added a gold-plated disc of greetings and other friendly messages, including the coordinates of our location, to introduce us to any civilization that comes in contact with any of the probes. But then again, this could be our biggest undoing. Imagine if aliens don't find our greetings friendly. Or what if they misinterpret it as a threat? Well, the dark forest theory will inevitably kick in at this point, and the existence of civilization in our universe will become the survival of the fittest, where the strongest life forms feast on the weaklings.